Hello students, let us solve one more problem from TIFR 2023. Question number is C11. Is basically from part C, question number 11. And this basic question is basically from atomic physics. And that subtopic is effect of finite nuclear mass in Bohr's model. So that question is mentioned that you have a hydrogen atom. The separation between two states of hydrogen atom is mentioned. You have a two states, n equals to 2 and n equals to 1. The separation is given as E naught. Okay. Now you have a muonic carbon. Muonic carbon. That is C5 plus. You have a muonic carbon. In fact, that carbon nucleus is mentioned as 612. Okay, muonic carbon, when there's a transition from n equals to 3 to n equals to 2 of muon particle in muonic carbon, the energy carried out by photon, that energy you have to calculate in terms of E naught. Okay. It's a very interesting question. If you solve this question, the concept of effect of finite nuclear mass in Bohr's model, that concept will completely be cleared. Okay, so let us discuss every steps. So now, if you include that effect of finite nuclear mass in Bohr's model, the energy of nth state I can write that will be mu by me, and then you have a En into Z square. The most general formula where En is the energy of nth state of hydrogen atom having infinite nuclear mass. You can represent like this, and Z is the atomic number. So first of all, I'll write that nth state energy for hydrogen atom. So obviously Z will be on, so I can represent mu by me, and then you have En, and Z is on, so obviously this will be the form. And mu will be how much? So as you know, if you see the structure of hydrogen atom, you have a proton sitting at the nucleus and electron is orbiting. So obviously mass will be, or reduced mass will be mp, and then you have a me divided by mp plus me. And you know mass of a proton, and that will be 1836 times mass of electron. So if we substitute it here, you will have reduced mass that can be written as 1836 divided by 1837 times me. Okay, so this is the reduced mass. Just this reduced mass I'll introduce here. Now I can define that energy separation, that is E naught of hydrogen atom, that can be written as E2 dash minus E1 dash. Now if you substitute this value, okay, if you substitute it here, that mu and En, then you will get 1836 divided by 1837, and then you have E2 dash and E1 dash. Yes, E2 dash and E1 dash. If you substitute that, you'll get that value, that will be 13.6. Then you have 3 by 4 electron volt. It means I can define on electron volt, and that can be written as E naught into 1837 into 4 divided by 1836, and then 13.6, and then 3. So this is the expression for on electron volt. I can define like this. Now I'll calculate that energy carried out by photon while there's a transition from n equals to 3 to n equals to 2 for muonic carbon system. Okay, so if you see the structure of muonic carbon 5 plus, The structure I can represent like, sorry, you have a 6 proton and 6 neutron sitting at the nucleus, and of course that electron is mu particle is orbiting, and mass of mu particle is provided, that is 208 times mass of the electron. Of course charge is given, that is minus c. Now I can represent that mass or energy of nth state of carbon 612. Okay, so that will be mu by me, and then you have en and 6 square. Okay, and mu will be here, that will be mass of the nucleus. We know mass of a proton and mass of a neutron is almost same, so total mass of nucleus will be 12 times mp, and then you have orbiting particle mass mu e divided by 12 mp plus mu mu. I'll substitute now mp and mu, so we'll have 12 then on 8 36 me, and then you have 208 me divided by 12 into on 8 36 me plus 208 me. Okay, so this is the reduced mass I have obtained. Okay, so I'll substitute that. Okay, so now if you calculate that energy carried out by photon when there's a transition from 3 for carbon to 2 of carbon, ionic carbon. So if you substitute, we'll obtain 12 into on 8 36, and then you have 208 divided by 12 into on 8 36 plus 208. Okay, and then you have z square, that factor is 36. Now E3 minus E2. So E3 minus E2 means basically minus 13.6 by 9 plus 13.6 by 4 electron volt, right? So just have substituted that values E3 dash and E2 dash. You have a reduced mass factor, then z square, and then E3 minus E2, that's the energy of second and first excited state of hydrogen atom while including infinite nuclear mass. Now I'll define, or I'll substitute that on electron volt here. If you substitute it here, you'll have E naught. Okay, you have E naught, and then on 8 37, and then 4 divided by 3 times on 8 36. Okay, and then of course 13.6. Okay, so these are the expression. Okay, so now if you calculate this value, the energy carried out by photon when there is a transition from second to first excited state of ionic carbon, this will be the energy of photon. If you simplify it, you'll get that value, that is 1373 E naught. Okay, okay, so according to that given option, this is very close to 1400 E naught. So they ask for closest value, so this will be the correct answer. Okay, thank you very much. 4 हो रहा है